Hello, and welcome to this lesson on solving proportions using cross products. So you may remember doing cross multiply in 7th grade. This is going to be a little bit more advanced than that. We're going to take it a step farther than some of the proportions you probably remember seeing in 7th grade. The essential question says, how do I solve proportions using cross products? That's cross multiply. Did you know that proportions actually do two main things for us, at least in 7th and 8th grade? The main things they're used for is first to check to see if two shapes are similar. If we have two shapes that we're not sure if they're similar, we can use a proportion to do that because similar figures are in proportion. And we'll learn about this skill later on in this school year. The other thing they're used for, proportions are used for, is if you have two shapes that you know are similar, like these two shapes I have here, they can be used to find the missing side of a figure. So in this problem here, if I set up this proportion, h over 24 equals 4 over 6, and I cross multiplied, that would find the missing side of the proportion, or the missing side of the height of that tree. So, I can show this now because it's a little previewing of the lesson. If I took 6 times h, I get 6h. And I took 24 times 4, 24 times 4 is 96. And then to solve the equation, you would divide by 6 because that's a multiply. Divide by 6 on both sides, and h equals, let's see, 96 divided by 6 is 16. So we could say the height of that tree is 16 feet. Okay, so that hopefully does look familiar to you. That is kind of the most basic solving proportion using a cross multiply that you probably did quite a bit of in 7th grade. And we're going to take that idea and we're going to expand it. So here we have one vocabulary word for this lesson. It is cross product. So cross product is the product of the numerator of one ratio and the denominator of another. Essentially, it is that cross multiplying. So if I would have the ratios a over b and x over y, the cross product is what I get if I multiply these two together, and that would be like a times y. And if I multiply those two together, b times x, and you set them equal to each other. This step right here, this is the cross product. That is what I get when I multiply them together. And that's the first step of solving the equation, because once you have a proportion, once you cross multiply the proportion, you now have an equation that we can solve. And you've seen, and we've done a whole bunch of solving equations in the past bunch of lessons. And we'll be doing more today. So the first problems here say just solve the equation. Be sure to check your solution. So this very first problem is kind of like that first problem I showed. It's a basic proportion. There's nothing too different about this than what you've probably seen in 7th grade. So when we multiply, we use this cross multiply. So I'm going to take 20 times 5, which is 100. I'm going to take 16 times by the m, which is 16m. That's the cross product. That was me cross multiplying. 16 times m is 16m. 20 times 5 is 100. Now, from here, we solve the equation. So this equation here, this 16m equals 100, I'm going to solve, because this is a multiply, I'm going to divide by 16 on both sides, and m should equal, wait, let me get rid of this 2, there we go. 100 divided by 16 should be 6.25. Now I'm going to check the solution here for this first problem. I'm not going to do it for every single problem. But to check this, we're going to do the same way we did in all the previous lessons. The way you check the solution to an equation is you plug the value that we got, the 6.25, in for the variable, and you see if the equation is true, if both sides of the equation have the same value. So check this out. 6.25 over 20. So that was me plugging in 6.25 for m. m over 20. 6.25 over 20 equals 5 over 16. Now use my calculator. 6.25 divided by 20 is 0.3125. And I want to know, is that the same thing as the other side of the equal sign? If I take 5 divided by 16, do I get the same value? And yes, I do. So that proves that m equals 6.25 is the correct solution, because when I plug it in, both sides of the equal sign have the same value. Now, letter B. This is now a bit harder. There's more to it. There's more than one variable, and we're not used to that. You're probably used to doing this. X times 8 is 8x. You probably are used to that. What you're not probably used to is taking 4 times by an expression. I need to take the 4 times by the whole expression, x minus 3. It's going to look like this. 4 times by the expression, x minus 3. And the way we're going to do that is just using our distributive property. I'm going to distribute 4 times by the x and 4 times by the 3. I'm solving right now. 12x minus, what am I doing? That's not 12x. My brain was working ahead. 4x minus 12 equals 8x. Now, as we're solving this equation, the normal steps would be to get rid of the variable on the right. We'd get rid of the 8x. I will say, though, that is probably not the best way to solve this equation. It will work fine, and that's probably what I'm going to do, but it would actually be a little bit quicker in this problem if we got rid of the 4x. If we got our x's on one side of the equal sign and our things without x's on the other. It's called isolating the variable. But it doesn't matter which method you use. I'm going to continue the way we have been doing, even though it's a little bit more work, but I like to be consistent. So I'm going to subtract 8x here. And this is also the way that you're more than likely going to make mistakes, and I can show you how you can fix those mistakes. So 4x minus 8x is negative 4x. It is a negative. And over here on this side, a lot of students struggle with what do they do here? Like when you take 8 minus 8 and you get 0 is gone, you don't put anything. No, you have to put something. It's still an equation. We just put the logical answer. You put 0. 8 minus 8 is 0. And now I solve. I'm going to add 12 to both sides to cancel out the minus 12. Negative 4x equals 12. Divide by negative 4 on both sides, and x equals negative 3. And there we have it. So to run through the problem one more time in case you needed it. So we started by cross multiplying. X times 8 was 8x. 4 times by the expression x minus 3 gave us 4x minus 12. I then solved the equation by subtracting 8x on both sides to get rid of the variable on the right. I then am trying to solve the equation to get the x by itself, so I get rid of the add and subtract. So I added 12 to both sides. And then finally, to get rid of the multiply by negative 4, I divided by negative 4 on both sides, and we got a solution of x equals negative 3. if I was going to check the solution, I would have to take that -3 for x and plug it in for all of the x's. I will check this one last problem and then I'll be done checking. So let's see, if I plugged in -3 for x, this is 4 over, I found x was -3. 4 over -3 equals 8 over -3 minus 3. And then for me to check, 4 divided by -3 is going to be a -1.3 repeated. And I want to know, does the other side, does the other ratio here have the exact same value? Well, 8, I'm going to use the fraction here, -3 minus 3. So I made this expression in my calculator, 8 over -3 minus 3 equals, go, that's a fraction. I'm not sure if that's the same thing. Well, this button here above the enter, this will allow us to switch from fractions to decimals. So if I click it, look at that, -1.3 repeated. So both sides had the same value, which means that is indeed the correct solution to this equation, or the correct solution to this proportion. Okay, we're going to do a few more. Now letter C will be solved almost exactly like the previous problem here. So I don't need him yet. I'm going to cross multiply. That is a 9x. I'm going to cross multiply. That is a 3 times by the x minus 4. 9x equals 3x minus 12. I distributed. I get rid of the variable on the right. That cancels. I have 6x equals -12. Make sure you bring down your negative. He's attached to the 12. They go together. Divide by 6 on both sides, and x equals -2. Yeah, I'm going a little bit faster in these problems. We should hopefully have enough practice and be familiar enough with solving the equations that these steps should hopefully be coming naturally to you. You can understand what I'm going to do before I'm actually doing it. If I'm going too fast for you, please pause the video when you need to get yourself caught up. But I am going to be solving the equations a little bit faster. Letter D. We're going to be solving the same. I'm going to take the 8 times by this expression, 8 times by n plus 8, and I'm going to take 3 times by this expression, 3 times by 5n minus 2. Both of those I'm going to be doing the distributive property. Distribute there is 8n plus 64. Distribute here is 15n minus 6. And then we just solve the equation. So I get rid of the variable on the right by subtracting to get rid of the positive 15. 8n minus 15n is a 7n plus 64 equals -6. Again, make sure you keep your negative. Don't drop it. And now I solve. I get rid of a plus 64 by subtracting 64 on both sides. 7n equals -70. Divide by 7 on both sides to cancel out the multiply. And n equals -10. And there we go. So hopefully you found them to be not terribly difficult. Steps would be cross multiply. Once you cross multiply, this becomes the exact same thing we've been doing in all of the other lessons. You're going to solve your equation, get rid of parentheses first, then you combine like terms if you need to. If you've got variables on both sides, get rid of the one on the right. Then we get rid of additions and subtractions, followed by multiplies and divides. Now the next few pages are going to be problems for you to try first, and then we'll go through them together. I will tell you here in these two problems, letter F is going to be easier than letter E. So maybe you want to try that one first. But pause the video, try these two on your own. When you're ready to continue, hit play, and we will go through them together. All right, let's do it. Hopefully you've done these already, so let's see how you did. So 1 times 3g is just 3g. 2 times by this stuff is... what is that? 2 times by this stuff is a 2 times by g plus 5. We are going to distribute the 2g through, so that gives me 2g plus 10. I'm going to get rid of the variable on the right, so I'm going to subtract 2g on both sides. We got g equals 10, and if you kept your 1 here, that's okay. You don't need it, but that's okay. Remember that any variable that you don't see a number in front of means that there is one of them. Technically, right here in my problem, this is 1g. So when I took 2 times 1, I got 2. In all my previous problems, wherever they are, that is a 1n. But you don't need to write the 1. That's a ghost 1. It's not needed in our problem. So I'm going to leave them out. G equals 10 is done. Letter F was much easier. This was kind of an old school cross multiply. Over here we've got 8x. On the left-hand side we're going to get 12. I'm going to divide by 8 on both sides, and we get x equals like 1.5 something. 12 divided by 8 equals 1.5. And we're done. So those two were fairly easy. Letter F was much simpler, much less work. But they're going to be getting progressively bigger, uglier, harder as we go. So here are the next two. Please pause the video, try these two on your own. When you're ready to continue, hit play, and we will go through them together. All right, let's see how you did. So I'm going to multiply. That's 2 times by h minus 1, and that is 5 times h plus 8. I'm going to distribute to get rid of the parentheses on both sides. So on the left, we have 5h plus 40. On the right side, we have 2h minus 2. To solve the equation, I am going to get rid of the variable on the right by subtracting 2h on both sides. So now we have 3h plus 40 equals a negative 2. Don't forget your negative. And I solve. Minus 40 on both sides. 3h equals negative 42. Divide by 3 on both sides, and h equals negative something. Negative 42 divided by 3 is negative 14. And we're done. Letter H. This, when I multiply, should be times 9, 504, yep. And this side, when I multiply, 126 times 4 is also 504, but this time we need a b. To solve the equation, I'm going to divide both sides by 504 to cancel out this multiply. And we get b equals 1. And that's done. And there's both problems if you wanted to see them before we move on to the next page. All right. In our quest to get bigger, uglier, harder, try these next two problems. Letters I and J. Pause the video, try them on your own. When you're ready to continue, hit play, and we will go through them together. Okay, letter I. cross multiply. That's what you do with proportions to turn them into equations. So on this side, I'm going to have 3 times by p plus 5. On the left side, I'm going to have 1 times by 3p minus 2, which I don't actually have to distribute this because if I'm multiplying by 1, I'm just going to get the same thing back. That's like a whole property of math. It's called the identity property of multiplication. If you take anything times by 1, you get the same thing back. But on the right-hand side, when I multiply by 3, I do get a 3p plus 15. All right. I've got variables on both sides. So when I subtract 3p on both sides, on the right-hand side, it cancels out. That's the whole reason why we did it. On the left-hand side, ooh, look at that. He also cancels out. 3p minus 3p is gone. We are going to get one of those special solutions. So we need to decide what type of special solution this has. So if you think back to the previous lesson, when your variables completely canceled out, I have no more p's left. If your resulting answer is true, that means your answer will always be true. You have infinitely many answers. Every single number is an answer to the problem. That's not what this is saying, because -2 is not the same thing as 15. This is not true. This is false. If your answer is false, we say that this problem is going to have no solution, because this is not true, which means our equation will never be true. So anytime you have multiple of the same variable in a problem, there's always the chance you could get no solution as an answer. Letter J. Cross multiply on both sides. I'm going to take 12 times by x minus 2 on the left and 6 times by x plus 2 on the right. I now solve the equation. I'm going to distribute 12x minus 24. I think I said right, on the left. On the right now, I take 6x and 12. So I distributed. I'm now solving. I'm getting the variable by itself. So I'm going to get rid of the variable on the right. I've got variables on both sides, so if I'm going to subtract 6x on both sides, we have 6x minus 24 equals 12. This is a two-step equation now. So we get rid of the add and subtract first. So I'm going to add 24 to both sides. 6x equals 36. And then finally, when you divide by 6 on both sides, we get x equals 6 as our final solution. So there's whole problem letter J for you to see. And there's the whole page. I think we have one more page of problems. Yep. And they are, again, a little bit bigger, uglier, harder, whatever. Pause the video, try them. When you're ready to continue, or if you get stuck, hit play, and we will go through them together. All right, letter K. This side is easy. 7 times 8 is 56. This side is also easy because I'm taking this 3x plus 9 and multiplying by 1, which means I'm going to just get 3x plus 9. It's times by 1. It's multiplying by it. You get the same answer. I solve the equation. To get this x by itself, I am going to subtract 9 on both sides. And then we have 3x equals 56 minus 9. That did divide. 56 minus 9 is 47. divide by 3 on both sides, and I don't know that division off the top of my head. X is 15.6 repeated. Our last problem, letter L. This was made a little bit uglier with the fact we have a 1/5 in our problem, just this fraction that we're going to have to deal with the whole way through the problem. It's going to make it a little bit ugly, but with the help of a handy-dandy calculator, it's not too bad. So we're going to cross-multiply like we have been doing. On the right side, we're going to take 7 times by 2x plus 9, which is going to be 14x plus 63. On the left-hand side, we're going to take the 3 times by a 1/5 minus x, which is going to give us 3/5 minus 3x. So now we have an equation we solve. I've got variables on both sides, so I'm going to get rid of the one on the right. Subtract it away. So it was a positive 14. I used a minus 14 to get rid of it. Minus 3x minus 14x is a minus 17x. We are going to get rid of our adding, subtracting by doing the opposite, but I'm not going to add 3/5. This is a common mistake. Some people look at this and go, oh, it's 17x minus 3/5. No, it's not minus 3/5. This 3/5 is positive. This 17 is negative. So in order to get rid of this 3/5, I'm going to subtract it away. Minus 3/5 on both sides. 63 minus 3/5 is 62 and 2/5. Check your calculator if you need to. Minus 3/5. I did 36. 63 minus 3/5. There you go. And then when you divide by negative 17 on both sides, x equals, divide by negative 17 equals negative 3 and 57 over 85. Kind of ugly, but it is the solution. All right, so that skill was all about just cross multiplying. If I gave you a proportion and I said find x, that's what we've learned to do. Now the next skill is, well, the problem solving part of it. Once you know how to find x, how can we use that to solve other problems? So this problem says, in the diagram below, triangle ABC is squiggle thing, triangle A prime, B prime, C prime. And you can see I have this squiggle thing labeled as similar. This is the symbol if two shapes are similar. This actually says, in the diagram below, triangle ABC is similar to triangle A prime, B prime, C prime. Find the value of x. Now we can do that relatively easily because if two shapes are similar, they are in proportion. So we can use a proportion to find missing sides, which I'm going to do. So I'm going to set up a proportion. Blank equals blank. When I set up my proportion, I like to pick two sides of one figure as a ratio. So x minus 2 over x plus 2. And then I pick the same two sides of the other figure. I make sure they're corresponding. So x minus 2 corresponds to 9.5. It's the same piece, AB, AB, but on the other picture. Now, I just cross multiply and solve. We're going to find x. We're going to do what we have been doing in the previous, I don't know, 6, 7, 8, 9, in the previous 10 problems we've done so far. So I'm going to cross multiply. I'm going to take, let me change color here. I'm going to take 12 times by x minus 2 and 9.5 times by x plus 2. And we solve. I'm going to distribute, 12x minus 24, distribute, 9.5x plus 19, that is 9.5 times 2 is 19. I'm going to solve my equation. Subtract 9.5x on both sides. These cancel out. We get not 100% positive on 12 minus 9.5. I'm pretty sure it's 2.5, but there we go. It's always good to double check yourself. That is not a 12. Minus 24 equals 19. I'm going to add a new page because I have no more space to write. Thank you. So I'm just going to continue further down. To solve the equation, I'm going to get rid of this minus 24 by doing plus 24 on both sides. 2.5x equals 43. And then finally, to get rid of this multiply by 2.5, I'm going to divide by 2.5 on both sides, and I have no clue what 43 divided by 2.5 is. It is 17.2. And there's probably a unit. Do we need a unit? Find the value of x. I mean, I guess technically it'd be centimeters. Doesn't ask us to find that. I don't know. But x is 17.2. So I set up my ratio for each triangle to make a proportion. We then cross multiplied, solve. Now, same type of thing, but harder. In the diagram below, w, x, y, z is similar to w prime, x prime, y prime, z prime. What is the difference in the areas of w, x, y, z and w prime, x prime, y prime, z prime? All right, so the difference in the areas means, well, the word difference means subtract. So I need to subtract the areas of these two. So I need to find the area of both of these figures, both of these rectangles, and then subtract them. Sounds simple enough. Well, let's see. First one, area equals length times width. Area is, and that's the formula for a rectangle, 8 times 18. Area is 8 times 18 is 144 yards squared. Cool. I found the area of the first one. 144. Now, if I can subtract the area of the second one, we got ourselves our final answer. But there's the problem. In my second rectangle, they don't give me nice, pretty numbers. They give me x plus 3 and 3x plus 6. And if I try to multiply these two things together, I'm going to get a bigger, ugly expression that we have no clue what we're looking at, and it's not going to be a number, and we can't find our area. So, what we'd like to do is if we could find out what this x is, then we could figure out how big this side is. Like, for example, if we solved and found x is 5, I'm playing pretend here. If x is 5, then I know, oh my, this side here would be 8, because 5 plus 3 is 8. And if x was 5, then this would be 15 and 6 is 21. And then we could find our area. So my goal here is I need to find x, to find how big the sides are, to find the area. And to do all that, we're going to set up a proportion because it says the two shapes are similar. So again, I'm going to make a new page here because I don't really have space to work it. All right, now we have space. So I'm going to use the proportion 8/18 equals x plus 3 over 3x plus 6. And I cross multiply. So 8 times by 3x plus 6. And 18 times by this gives me 18 times by x plus 3. A little squished there, but that's okay. I distribute because I'm solving an equation. On the right-hand side, I get 24x plus 48. On the left-hand side, I get 18x plus, I don't know, 18 times 3 is 54. And we keep solving. I've got an equation with variables on both sides, so I get rid of the 1 on the right. I'm subtracting 24x on both sides. That gives me negative 6x plus 54 equals 48. I'm still solving. I'm getting the variable by itself, so I'm going to get rid of this add and subtract before I get rid of the multiply and divide. So I subtract 54. That's not a 54. That's a 54 on both sides. Negative 6x equals negative 6. And then finally, when I divide by negative 6 on both sides to cancel out the multiply, we get x equals 1. So we've found that x is 1. Now remember our game plan. We needed to find x because we needed to know how big these sides were. X is 1. X is 1. So that tells me that this side here, well, I should say this side here, has a length of 4 because 1 plus 3 is 4. This side down here, my bottom side, is 3 times 1 plus 6. So that's 3 plus 6 is 9. And I know the area of that rectangle now because area equals length times width, and 4 times 9 is 36. And we're finally ready for the last step of this problem. Finding the difference of the areas. So I have area of the big guy, area of the little guy. Ooh, that's a 6. That's a 36. And then when I subtract the areas, 144 minus 36 is 108 yards squared. The answer is 108 yards squared. And then all of this work was just to get us there. That was finding the area of the big rectangle, setting up a proportion, comparing both rectangles because they're similar, solving the equation, solve, finding x is 1, plugging x of 1 in for x in our second rectangle to find the length of its sides, finding the area of the second rectangle, and then finally subtracting the areas. Find the difference of the areas. That was a very hard problem. That was a long problem. So give yourself a little stretch if you need to. But we're moving on. I think we've got one problem left. We do. Last problem. So this is one for you to try first. It says if JKLM is similar to J prime, K prime, L prime, M prime, find the perimeter of JKLM. So if the two shapes are similar, find the perimeter of JKLM. Pause the video, please. Try this on your own. When you're ready to continue, hit play, and we will go through this together. All right, so perimeter is what you get if you add up all the sides of a figure. Add all sides. And I can't do that because, well, I know this is 6, and I know its opposite side is 6, but I don't know what the top and the bottom are. I don't have a number there. It's just x plus 6. So we need to find x, just like the previous problems. In order to find x, we're going to set up a proportion, and then we're going to cross multiply, and then we go from there. So let's do it. And I got a little bit more space, so I might be able to fit everything in here. So my proportion is going to be this versus that. So 6, I almost put centimeters. I don't need units in my proportion. 6 over x plus 6 equals 1.5 over x minus 6. I think I'm going to make another page. There we go. Now I don't have to worry about moving stuff around too much. I cross multiply. 6 times by x plus 6. 6 times by x, x minus 6, I mean. And on the other side, 1.5 times by x plus 6. So I'm cross multiplying. Now I'm solving. So I distribute 6x minus 36, 1.5x plus 9. Now I'm solving. I'm getting the variable by itself, or starting by getting them on the same side, getting rid of the variable on the right. 4.5x minus 36 equals 9. Now I'm getting the variable by itself. We get rid of adding and subtracting first, so I add 36 to both sides. And 4.5x equals 45. Divide by 4.5 to cancel out this multiply. Divide by 4.5, and x equals, I'm pretty sure that's 10. 45 divided by 4.5 is 10. Not the answer. That's x. So x is 10. In the whole problem, x is 10. X is 10 right here. X is 10 over there, but we don't really care about the small rectangle because the original question was find the perimeter of JKLM. That's this big one. So I know this is 6 and this is 6. I now know that the big side is a length of 16 and 16. So then when I find perimeter, I'm going to add all these sides together. 6 plus 16 plus 6 plus 16 more gives me a perimeter of 100, gives me a perimeter of 44. So 6 plus 16 plus 6 plus 16 equals 44 units, centimeters. I looked at the other rectangle. The other rectangle is in centimeters. So there we have it. That wasn't too bad. We had to set up a proportion to find x. We needed x to find the side lengths. We needed the side lengths to find the perimeter. Summary. So this is the last lesson of this unit on solving equations. So can you come up with, on your own, at least one real-life situation where setting up an equation could be useful? Think about it, pause the video, come up with an idea or two. When you're ready to continue, hit play, and we'll go through it together. So this is used all the time. Anytime you're doing, you're calculating something. I mean, if you're trying to figure out if you've got enough gas in your car to make it to the beach. I mean, you currently have 125 miles on that you've driven on your new tank of gas, and you know your car normally gets like 400, and then using Google Maps, you know that the beach is, I don't know, 250 miles away. Well, would you make it 250 miles? You could use an equation to figure that out. If you took 400 minus 125, so you would have 275 miles on your tank, and you only need 250. So yeah, you'd make it with 25 miles to spare on your gas tank, with like about a gallon left in your tank. It's used for all kinds of things. Anytime you're building something and you're measuring and you're calculating, that's a place you can use an equation. Anytime you're trying to budget and you're saying, well, do we have enough money for this? That's a place you can use an equation. Okay? So equations are used everywhere, and you're going to use them a lot of everywhere in your life. This has been the lesson on solving proportions. Thanks for watching. Toodles.